Hello, dear students. Let us study about the preparation of alkenes. Here we are going to study a very important method for the preparation of alkenes. And even in this method, my dear students, we can have this opportunity to prepare the cis alkene or trans alkene. And that is why this method is very important and very interesting. Here, the reagent that we use for the preparation of a cis alkene is known as the Lindlar's catalyst. So, let us study now about the preparation of alkene. Preparation of alkene from alkynes by the Lindlar's catalyst. Alkynes on particular reduction, alkyne on partial reduction with calculated amount of dihydrogen in the presence of pelletized charcoal. Partially deactivated. This pelletized charcoal is partially deactivated with the poisons like sulfur compounds or quinoline. Gives cis isomer of alkane. Cis isomer of alkene. Partially deactivated pelletized charcoal is known as Lindlar's catalyst. So first of all, my dear students, we need to know that what is Lindlar's catalyst? Lindlar's catalyst, Lindlar's catalyst is partially deactivated pelletized charcoal. So partially deactivated pelletized charcoal. This is how we represent it. Now, how it is partially deactivated? Partially deactivated with poisons. Which are the poisons? Here we have the poisons like sulfur compounds or quinoline, and it is pelletized charcoal. Please remember. So this partially deactivated pelletized charcoal, which is deactivated by the poisons like sulfur compounds and quinoline, is known as the Lindlar's catalyst. Please remember this because this is what it may be a very important question for your exams. So partially deactivated pelletized charcoal, which is deactivated with the sulfur compounds or quinoline, is known as the Lindlar's catalyst. Lindlar catalyst is used to obtain the alkene from alkynes, and when we use the Lindlar's catalyst, we get the cis alkene. So here you can see in the chemical reaction that we have an alkyne RC triple bond Cr dash. If we add hydrogen and if we have the pelletized charcoal into it, so in the presence of pelletized charcoal, we will get the cis alkene where both the R and R dash are of the same side, whereas both the hydrogens are also at the same side. Let us see it with one more example. If we have 2-butane, if 2-butane is allowed to undergo the reaction with hydrogen in the presence of Lindlar's catalyst, we shall get cis-2-butene, where you can see that both the hydrogens are on the same side of a double bond and both the methyl group are on the same side of the double bond. Now, how can we get the trans-2-butene or trans-alkene? So, for the preparation of trans-alkene, alkynes are allowed to undergo the reduction with the presence of the sodium metal and liquid ammonia. So in the presence of the sodium metal and liquid ammonia, if alkynes undergo the reaction with hydrogen, it gives us the trans alkene. So this is how, my dear students, we can easily understand the preparation of trans alkene. 2-butane, when it undergo the reaction with hydrogen in the presence of sodium metal and liquid ammonia, it will gives us the trans 2-butene. So please remember, my dear students, that Lindlar's catalyst, which is partially deactivated pelletized charcoal, will give us the cis alkene, but the sodium metal with liquid ammonia, if it is allowed to react with alkyne, it gives us the trans alkene. And this is how we can prepare the various alkenes from alkynes. So it's a simple process, my dear students, by which we can prepare alkene from alkyne, and we have an opportunity that we can prepare cis alkene or trans alkene as a major product using the various reagents. Now, my dear students, we want to study about the various chemical properties of alkene. While studying the various addition reactions, my dear students, we have studied about very important properties of alkenes like addition of HBr, and we have even studied about the ozonolysis of alkene. Now, those property which we did not study, let us study them here in this portion. First, my dear students, we want to study about the addition of halogens. Halogens like chlorine and bromine are added to alkenes sorry, to give vicinal dihalides. Dihalides having two halogen bonded to neighboring carbon. So what is vicinal dihalide? Vicinal dihalide is a kind of dihalide which is having two halogen bonded to the neighboring carbons. So this kind of product when we get when we add halogen to the any alkene in the presence of carbon tetrachloride. So here you can see that we have a propene. This propene, when it is added to chlorine in the presence of carbon tetrachloride, we get 1,2-dichloropropene, which is a vicinal dihalide. Please remember, vicinal dihalide is a dihalide in which two halogen atoms are bonded to the neighboring carbon. Same way, my dear students, when we make the bromine solution in carbon tetrachloride, that is CCl4, bromine solution in carbon tetrachloride is a red color solution. Please remember that bromine solution in carbon tetrachloride is a red color solution. When this red color solution is added to alkene, bromine adds up itself into the alkene and give vicinal dibromide. Thus, the red color of bromine solution disappears. So when we add a bromine water or a bromine solution in carbon tetrachloride to any alkene, which is having the double bond, the red color of bromine disappears. This is the test for the unsaturation. Thus, alkenes which are unsaturated compound make red colored solution of bromine into the colorless solution. This is the test for the unsaturation. That means the presence of double or triple bond. So here you can see that this propene, my dear students, when it reacts with bromine, it forms 1,2-dibromopropane, and the red color, this red color disappears. And as the red color disappears, my dear students, this we can use as a test for the unsaturation, whether it is the test for the double bond or it is the test for unsaturation for the triple bond. So I hope now it's clear to you that we can use this such chemical reaction for the test for unsaturation. Test of unsaturation. Unsaturation, that is double bond or triple bond, can be tested by two different ways. The first way is by decolorizing the bromine in CCl4. There is one more method also available, my dear students. That is what it is known as the by decolorizing the Bayer's reagent. That is, what is Bayer's reagent? Bayer's reagent, that is the aqueous solution of potassium permanganate. So now, my dear students, we are going to study about the next test for unsaturation, and that is what it is, the Bayer's test for unsaturation. Let us study the Bayer's test for unsaturation. First, that we need to know what is Bayer's reagent. So cold alkaline dilute aqueous solution of potassium permanganate is called the Bayer's reagent. So what is Bayer's reagent? Cold alkaline aqueous potassium permanganate solution. That is what it is known as the Bayer's reagent. When alkene react with the Bayer's reagent, pink color of KMnO4 discharge. Discharge means disappears. Or we can say vanishes. So when any unsaturated compound reacts with the Bayer's reagent, its pink color vanishes, pink color discharges, and brown precipitates of manganese dioxide are formed. So if we add any substance to the Bayer's reagent, and if its pink color disappears and brown precipitates are formed, we can easily say that the substance has got unsaturation or the substance has double or triple bond present with it. Decolorization of KMnO4 solution by alkene is the test for the unsaturation called Bayer's test. So here you can see that if we have alkene like ethene, when it undergoes the reaction with the dilute KMnO4, which is the Bayer's reagent, it forms the ethane 1,2-diol, which is also known as glycol, and the pink color disappears and we get brown precipitates of MnO2. Here, my dear students, please remember that this is what it is known as the ethane 1,2-diol formed. This ethane 1,2-diol is also known as glycol. Please do not forget these names because they are also important. Now let us move forward and understand the next one. Same way, my dear students, if we have propene, when it reacts with water and dilute KMnO4 solution at 273 Kelvin, we are going to get pentane 1,2-diol. Please remember, my dear students, that the same kind of reaction is also possible with the alkynes. Acidified potassium permanganate or acidic potassium dichromate. Please remember, my dear students, I am talking about acidified potassium permanganate, that is your KMnO4 acidic, and acidic potassium dichromate, it is your acidic K2Cr2O7. So these are the very good oxidizing agent. They are either the acidic potassium permanganate or acidic dichromate, acidic potassium dichromate. They are very good oxidizing agent and they oxidizes the alkenes. They oxidize the alkenes to the ketones and or acids depending upon the nature of alkene and experimental conditions. So please remember, my dear students, that these alkenes, when they react with the either KMnO4 or K2Cr2O7, we can get either an acid as a product or we can get the ketone as a product. Let us see what happens. If we have 2-methyl propene, let me show you the structure of 2-methyl propene. See, you have CS3, then C, CS3, double bond CS2. This is 1, 2, and 3. It's a 2-methyl propene. When this 2-methyl propene undergoes the oxidation with KMnO4 in the presence of acid, or we can say acidified KMnO4 or acidified potassium dichromate, it gives us the propane 2 on, my dear students. This propane 2 on is CS3, C double bond O, CS3. Along with that, we can get carbon dioxide and water. So please learn this reaction that in the presence of acidified potassium permanganate, we get propane 2 on. Same way, my dear students, if we have but2 in, This but2-in has, if we allow it to react with the acidified potassium permanganate, we are going to get two molecules of ethanoic acid. So here you can see that this kind of cleavage takes place, and this CH3CH is converted to CH3COOH. The another CH3CH part is also converted to CH3COOH, and but2-in, when it is oxidized with the vigorous oxidizing agent or very strong oxidizing agent, that is acidified potassium permanganate, we get ethanoic acid. So what we study here, my dear students, that we have some strong oxidizing agent. Our potassium permanganate, which is acidic, or if we have potassium dichromate, which is acidic, these two are the very strong oxidizing agent, and they convert alkenes to either ketone, or they can be converted to carboxylic acid depending upon the reaction condition. And I would like you to, or I would like to request you that you please learn this kind of reactions, because they may be asked into your next exam. Now, my dear students, we want to study about the polymerization of alkenes. Polythene is obtained by the combustion. Polythene is obtained by the combination of large number of ethene molecule at high temperature and high pressure, and in the presence of catalyst. The large molecule thus obtained is called polymer. My dear students, in the previous tangents, you have already studied about polymers. Polymers are the large molecules which have large molecular weights. They have the repeating units. These repeating units are known as the monomers. So here our ethene is used as a monomer, and by combination of so many ethene molecules, we get a large molecule. This large molecule is obtained in the presence of some catalyst at high pressure and high temperature, and this is what it is known as polythene. This polythene, what we get is known as, it is a polymer. The process of obtaining polymer from monomer is known as the polymerization. What is monomer? The simple compound from which polymers are made are called the monomers. So these are the definitions by which you can understand the meaning of the word polymer. You can understand what is polymerization, and you can even understand what is monomer. Sometimes they ask you this definition, so you should learn it. Now let us see how polythene is formed. If you take huge amount of molecules of huge amount of molecules of ethene, and for that we have put N. So huge N represent the huge amount of molecules of ethene at high temperature and high pressure. In the presence of catalyst, it is converted to polythene. Same way, my dear students, if you take huge amount of uh, propene, my dear students, at high temperature and pressure in the presence of catalyst, we may get polypropene. So please remember, this is what it is, your polypropene that you get. Please remember that in polypropene, the methyl group is available as a branch. So in polypropene, we have methyl group available as a branch, and there is a 2, and this is the kind of way by which we represent the polypropene. Now let us study some of the uses of polythenes. Uses of polythene. Polythene is used for the manufacture of plastic bags, squeeze bottles, refrigerator dishes, toys, pipes, radio and TV cabinets. So please remember that our polythene is used to prepare the various types of plastic bags. It is also used to make the squeeze bottles. It is also used for the manufacture of refrigerated dishes. It is used for the manufacture of toys. It is used for the manufacture of pipes, and it is also used for the making the radio or TV cabinets. Now, my dear students, we are going to study the uses of the polypropylene. Polypropylene is used for the manufacture of milk crates, plastic buckets, and other molded articles. So this is how we studied about the various uses of polythene and polypropylene, and that is how we complete our discussion about the alkenes. Now, my dear students, we want to study about the alkynes. Alkynes are the hydrocarbon in which at least one carbon-carbon triple bond is present. Now, let us see how we can prepare the alkynes or ethyne. So, preparation. First preparation is the preparation from calcium carbide. On industrial scale, ethyne is prepared by treating calcium carbide with water. Calcium carbide is prepared by heating quicklime with coke, and quicklime is prepared, or quicklime is obtained by the heating limestone. So let us study this reaction with the chemical equation, my dear students. First we take limestone, which is heated to give us the quicklime. This quicklime, when it is treated with coke, it gives us calcium carbide and carbon monoxide. And this calcium carbide, when it reacts with water, it gives us the ethyne, that is your C2H2. So it's C triple bond C, H, and along with the calcium hydroxides. It's a quite simple method to understand, my dear students, so we can understand it very easily. Now, my dear students, we want to study about the another method of preparation of preparation of ethyne or alkyne, that is from the vicinal dihalide. We are already aware that vicinal dihalide is the dihalide that has two halogens, two halogen atoms bonded to neighboring carbon. Or instead of neighboring carbon, we can write it as adjacent carbons. So here we take a vicinal dihalide. This vicinal dihalide on treatment with alcoholic KOH, my dear students, give alkenyl halide. This alkenyl halide on treatment with sodamide, that is, the sodamide is nothing but NaNH2, gives us the alkyne. So let us look at this. This is what it is, your vicinal dihalide. You can easily see, my dear students. This is vicinal dihalide. Or we can say it is vicinal dibromide. On a treatment with alcoholic KOH, my dear students, it gives us the alkenyl halide. And this alkenyl halide in the treatment with the sodamide, it gives us the ethine. Both these reactions or both these steps are the steps of elimination reaction. And please remember, this is also a kind of elimination which is known as the beta elimination reaction. So we have already studied about the elimination reactions, and it is beta elimination reaction. Now let us study the various chemical properties of alkynes, my dear students. So ethyne, dear students, when it is added to hydrogen in the presence of the catalyst platinum, palladium or nickel, it gives us the ethene. And ethene is also further added with hydrogen in the presence of catalyst, it gives us the ethane. So please remember that addition of dihydrogen to the alkyne gives us alkane as end product. In between, we can even get alkene from the alkynes. Same way, my dear students, if we have propyne and if we allow two molecules of hydrogen to be added in the presence of the catalyst, we can get propane as an end product. Now, dear students, we want to study about the addition of halogen into the alkyne. So when alkyne like propyne is added to the bromine, we get 1,2-dibromopropene. This 1,2-dibromopropene is again the vicinal dihalide that we get. And then again on adding the another bromine to the 1,2-dibromopropene, we get 1,1,2,2 tetrabromopropane. We get 1,1,2,2 tetrabromopropane. Here we can get 1,1,2,2 tetrabromopropane, which is an saturated product. Then, my dear students, we have the third kind of reaction that we want to study about, which is the addition of hydrogen halide. Two molecules of hydrogen halide like HCl or HBr or HI, when added to the alkyne, we get a geminal dihalide. Now please remember, here we have the another type of dihalide which is known as the geminal dihalide. What is geminal dihalide? A dihalide in which both the halogen atoms are bonded to the same carbon. This type of dihalide is known as the geminal dihalide. So you can see that if we have ethyne and if we add two molecules of HBr, on the addition of the first HBr, we will get one bromoethene, and this one bromoethene on addition of HBr will give us the 1,1-dibromoethane, which is known as the geminal dihalide. Same way, my dear students, if we look into the next one, if we have a ethyne, this ethyne when it reacts with the HBr, it gives us the 2-bromo. It's not ethyne, my dear students, it's propyne. And when it reacts with, when HBr is added to it, we get 2-bromopropene, and 2-bromopropene when further added with the HBr, we get 2,2-dibromopropane, which is again the geminal dihalide. So please remember, my dear students, that if you have alkyne and if you had halogen, you will get vicinal product, and if you add HX, that is hydrogen halide, you will get geminal product. Please remember this. It is going to be a very important point for the exam concern. Now, addition of water to the alkynes. My dear students, let us study the addition of water to the alkynes. Generally, what happens that the alkynes are immiscible in water, but on warming with the mercury sulfate and on dilute sulfuric acid at 333 Kelvin, they form carbonyl compounds by the process of isomerization. So here if you take the ethyne, my dear students, and if you allow it to react with water in the presence of mercuric sulfate and acid like sulfuric acid at 333 Kelvin, first you get an enol form. This enol form is called enol because here we have double bond present, that is in, we have alcohol present, that is all, and that is why this form is known as enol form, and this enol form is isomerized to give us the aldehyde which is known as the ethanol, CH3C double bond OH. Now, how this takes place, that you can understand that the electron of this double bond, they come here, and this hydrogen, it's simply bonded to this this hydrogen, sorry, this hydrogen which is present in the alcohol goes to the another carbon, goes and combine with this carbon. So that is how you get the aldehyde produced. Same way, my dear students, if you take propine and allow it to react with the alcohol in the presence of mercuric sulfate and sulfuric acid at 333 Kelvin, again you get an enol form. And here from this enol form, the hydrogen goes to the carbon with the double bond, and the electron from the double bond, they come between the carbon and oxygen, and thus from that we can get the keto from, and we can have propanone as a one of the important products. So this is how we can understand the various reactions of the alkynes, my dear students. Now we want to study about the polymerization of alkynes. So my dear students, ethine undergoes two types of polymerization. Please remember that ethine undergoes the two type of polymerization. One is the linear polymerization. Under suitable conditions, ethine undergoes the linear polymerization so that we get polymer or polyacetylene. So polythene or polyacetylene is a high molecular weight polyene. It has repeating unit CH double bond CH bond CH double bond CH. It can be represented as N repeating unit of CH double bond CH double bond CH. And under special condition, this polythene conduct the electricity. This is the very important point, my dear students, that this polythene can conduct the electricity. As polythene can conduct the electricity, the thin film of polythene can be used as a electrode into the batteries. These films are good conductors of heat and electricity. They are lighter and they are cheaper than the metal conductors. So please remember that this is how we can study about the uses of polythene. Please remember that in a special conditions, this polythene can conduct electricity, and that is why it can be used as an electrode into the batteries, and these are cheaper than metals, but they are uh, a good conductor of electricity. Then we have, my dear students, the another kind of polymerization of ethine, which is known as the cyclic polymerization. Here in the cyclic polymerization of ethine, my dear students, ethine on passing through the red hot iron tube at 873 Kelvin undergoes the cyclic polymerization. So three molecules of ethine polymerizes to give us benzene. It is a very important reaction. This cyclic polymerization of ethine is a route for entering from aliphatic um, to the aromatic compound. So this is how we can go from aliphatic compound to the aromatic compound. So you can see here that we have the three molecules of ethine. We have three ethine molecules. These three ethine molecules, when passed from the red hot iron tube at 873 Kelvin, it undergoes the aromatization and we get benzene produced over here. Benzene is a starting molecule for the preparation of derivatives of benzene. That means the various groups, when they are attached to benzene, this kind of compounds are known as the derivatives of benzene. We can even prepare the drugs, dyes, and large number of other organic compounds from the benzene. So it's a wonderful way entering into the aliphatic to aromatic um, compounds. Now, my dear students, here I am going to show you the various nomenclature way or names of the various aromatic compounds. Though we have already studied it into the previous period, but I thought let me give you the revision. So here we have benzene. When we have two benzene rings, we call it naphthalene. When three benzene rings are arranged in a linear manner, we call it anthracene. But two benzene rings are present in the linear manner and one is above it, we call it phenanthrene. If two benzene rings are bonded with each other with the single carbon, then we call it biphenyl. Here you can see that there are two carbon which are bonded directly and they have two carbon common, but in biphenyl there is no carbon common between the benzene rings. If benzene has got methyl group bonded to it, it is known as the methyl benzene or toluene. My dear students, if we give number to the various six carbon of benzene, then our 1 2 position and 1 6 positions are same, which is known as the ortho position. Our 1 3 position and 1 5 positions are same, which is known as the meta position, and 1 4 position is known as the para position. So if you have the two methyl group on a neighboring carbon, we call it orthoxylene or 1 2 dimethyl benzene. If two methyl group are located at para position, that is 1 4 position, we call it paraxylene or 1 4 dimethyl benzene. Or if two methyl group are present at 1 3 position, even if they are present at 1 5 position, we are going to call them metaxylene. So please remember this. This way we can give the nomin or names for the compound which are having more than one uh, group bonded to benzene. If benzene has got hydroxy group bonded to it, we call it phenol. If benzene has got NO2 group, we call it nitrobenzene. If benzene has got OCH3 group bonded to it, we call it either methoxybenzene or anisole. If benzene has got COCH3 group bonded to it, we call it acetophenone, but IUPAC suggests that it should be called 1-phenyl ethane 1-on. This is the important name, my dear students. Please learn it well. Then if benzene has got COOH group bonded to it, we call it benzoic acid. When benzene has got CHO group bonded to it, we call it benzaldehyde. When benzene has got SO3H group bonded to it, we call it benzene sulfonic acid. Please remember, my dear students, that if at 1 2 position or 1 6 position, if toluene has got hydroxy group or phenol has got methyl group, we call it orthocresol. Same way, if methyl and hydroxy group are at meta position, we call it metacresol. And if methyl and hydroxy group are at para position, we call it, or 1 4 position, we call it paracresol. This is a very important question for the nomenclature of benzene, my dear students, that we have CS2 double bond CH, CS3, CS2 and a phenyl ring. So we will call it as a phenyl ring, and this phenyl ring is bonded to the fourth carbon, so we will call it 4-phenyl but 1-in. Here the functional group is alkene and that is why it should be given preference, and that is why the numbering is done where the carbon bonded to or carbon involved into the alkene get the list number. Once again, it is 4-phenyl but 1-in. Then, my dear students, if benzene has got ethyl group bonded to it, it is called ethyl benzene. Suppose all the hydrogen of benzene are replaced by the chlorine, then we call it hexachlorobenzene or benzene hexachloride. So these are the various names I wanted you to learn about. Please learn them. Then we have the preparation of benzene, my dear students. We have already studied various preparation of benzene. So by aromatization, we are very well aware that when hexane undergoes the reaction or aromatization at 773 Kelvin and 10 to 20 atmospheric pressure in the presence of catalysts like Cr2O3 and V2O5 or MO2O3, we get benzene. Same way, my dear students, we can have benzene by the other method, which is known as the decarboxylation reaction or soda lime reactions. So if we have sodium benzoate, it undergoes the reaction with 3 is to 1 sodium hydroxide and calcium oxide. This is what it causes the decarboxylation, and we get benzene and sodium carbonate. Same way, my dear students, the benzene can also be prepared by the cyclic polymerization of ethine. So ethine, when it is passed, or three molecules of ethine, when they are passed through the red hot iron tube at 873 Kelvin, we get benzene, my dear students, and benzene can also be obtained by the reduction of phenol. Reduction of phenol is done with the zinc dust, and zinc dust, when it reduces the phenol and gives us the benzene, and zinc itself is converted or oxidized to zinc oxide. So these are the various preparations of the benzene, my dear students. Now it is very important to study the reactions of the benzenes. My dear students, benzene undergoes the special kind of reaction. This kind of reaction is known as the electrophilic substitution reaction of benzene. In the electrophilic substitution reaction of benzene, my dear students, benzene reacts with the attacking reagent. Attacking reagent, we have already studied about the attacking reagent. Benzene here behaves as a substrate, and when this attacking reagent is when the attacking reagent is electrophile, which is electron deficient, it attacks on the benzene and gives us the substituted product. This substituted product, we can also call it as a benzene derivative. Please remember that we can have the various benzene derivatives, my dear students. This type of reactions, which are known as the electrophilic substitution reactions, we can have nitration, we can have sulfonation, we can have halogenation, that means chlorination, bromination, we can have Fiedel-Crafts alkylations and Fiedel-Crafts acylation in this regard. So let us study now the various types of electrophilic substitution reactions and these various reagent used for the electrophilic substitution, and then what are the electrophiles produced. For nitration, my dear students, we use concentrated nitric acid and sulfuric acid. So the mixture of concentrated nitric acid and sulfuric acid is used for nitration as a reagent or for the nitration, and we get the electrophile NO2 plus. Same way for halogenation, my dear students, we can use FeX3 oblique X2. That means we can use FeCl3 oblique Cl2 for chlorination, and we may even use FeBr3 oblique Br2 for bromination, or we can use AlCl3 and X2. That means we can use AlCl3 oblique and Cl2, or we can use AlCl3 and Br2, and thus we can find the halogen cation as a electrophile. So we may have Cl plus 2 or Cl plus 1 or Br plus 1 as an electrophile during the mechanism. Same way, my dear students, if we study about the sulfonation, then for sulfonation, we use the reagent which is known as the H2S2O7. That is also known as the oleum or fuming sulfuric acid. And here the electrophile produced is SO3H plus. For Friedel-Crafts alkylation, my dear students, we can use anhydrous AlCl3 as a reagent, and we can use RCl. This RCl may be CH3Cl or C2H5Cl, and the various electrophile that we may have. It may be CH3 plus or it may be C2H5 plus, my dear students. So on the basis of that, we can understand the Friedel-Crafts alkylation and Friedel. Now, if we go for the Fiedel-Crafts acylation, the reagent that we use is anhydrous AlCl3 or RCOCl. We can even write it as a CH3COCl. And then in this reaction, my dear students, the electrophile we get is RCO plus or CH3CO plus. So these are the various reagents that we use for the different kind of electrophilic reactions, and we have even seen the different electrophiles produced during this reaction. I hope, my dear students, you are enjoying your studies. Happy learning.